Hello and welcome to this video. So first thing is that I have got some feedback that I should slow down. So I will slow down and the result is that video will be longer. The second thing is that in the next video I will show plots of functions and how roots are there and how the functions behave. So there will be several plots so that you can understand. Because in last video or last couple of videos we have seen that the plot of function, the rate of change and all that have come into picture. So I thought a video on that will be useful and I'll make that. The third thing is that we will not solve problem number 498. This is the 50th set of the problems on theory of equations and polynomials. We will not solve question number 498 because there are serious issues in the typing. The fourth thing is that in the last video, if you have watched one, then for the question number 483, I got confused, and yesterday was basically a bad day for me for personal reasons. So we will look at the solution of 483 again and try to understand what is going on. You must watch the previous video to understand this entire context. So question 483 we revisit. It says that if the equation ax square minus bx plus c is equal to 0 has two distinct real roots between 1 and 2 where a, b, c are in the set of natural numbers, then show that a is greater than or equal to 5 and b is greater than or equal to 11. So if you look at the previous video, you will see that the problem was, let me do the text selection. Okay. The problem was this one, okay? That is 0 less than alpha, 1 minus alpha, comma beta, comma 1 minus beta less than 1. This is incorrect. The reason it says that roots are between 1 and 2. So the correct statement should be 0 less than alpha, comma beta, 1 less than alpha, comma beta less than 2. And the second statement should be written like alpha minus 1, 0 greater than alpha minus 1, comma beta minus 1 less than 1. So alpha beta will lie between the 1 and 2, but alpha minus 1 and beta minus 1 will lie between 1 and 0 and 1. So see, everything else remains same. This condition becomes different, and this becomes 1 alpha minus 1, this becomes alpha minus 1, this becomes beta minus 1. So, and these two also become beta minus 1. So this product will remain unchanged and everything remains unchanged. So if you want, you can go ahead and look at the solution I have shown you for you. So I will not revisit the entire stuff again. So let's go on and solve up to question 500. So we start with question 491. So it's a very easy question. It says that 1 by integral part of x plus 1 by integral part of 2x is equal to fractional part of x plus 1 by 3, where integral part denotes the where a bracket of x, that is this symbol, denotes the integral part of x, and x inside braces is equal to, that is the fractional part of x, is equal to x minus obviously the integral part of x. So we have this equation. Now you see that integral part of x cannot be negative because that will make left hand side negative. So this will become negative. But the right hand side will remain positive because fractional part is always positive. Now we look at case 1. Okay. So case 1 says that fractional part is greater than or equal to 1 by 2. So in this case, this 2 should be inside the bracket. So in this case, the integral part of twice that of x is equal to 2 into integral part of x plus 1. So I'll give you an example. if the number is 1.6, then twice of that is 3.2. So the integral part of 2x would be 3, but the integral part of x is 1. So 3 is equal to 2 into 1 plus 1. So that's how we arrive at this. So here n is in the set of positive numbers. Now we put integral part is equal to n. So the equation becomes 1 by n plus 1 by 2n plus 1 minus 1 by 3. Now you put x is equal to 1, 2, 3, it will never be satisfied and the function is decreasing in nature. So once it becomes negative, then it will never become positive. So it will not match with this. Now we take the second case that fractional part is less than half. So the fractional part becomes 1 by n plus 1 by 2n minus 1 by 3. So it is basically 9 minus 2n by 6n. So again you see that numerator becomes negative once n is greater than or equal to 5. So those values are ruled out. So you also see that x is equal to 2, 3, 4 are the only values which satisfy the given equation. So we have that. So that's how we arrive at the solution of 491. Question 492 says that solve 6 by 5 a to the power log of x with base a into log of a with base 10 into log of 5 with base a minus 3 log of x by 10 with base 10 is equal to 9 to the power log of x with base 100 plus log of 2 with base 4. So again very straightforward question. So we let k is equal to log of, that is whatever is the power of this a. Okay, so that is what we have taken as k. Now if you look at first two product terms, this can be written as log of x by log of a, and this can be written as log of a by log of 10. So log a can be cancelled and it will become log of x with base 10. Now this will be in multiplication with this term, so we take the entire stuff and raise to the power of 5. So that's how we get this. Now we take antilog of this. If you take antilog of this with k, the left hand side will become a to the power k is equal to 5 to the power log of x with base 10. And then we let log of x with base 10 is equal to L. Now we look at this power. So it becomes log of x by 10 with base 10, that is log of x with base 10 minus log 10 of 10. 10 with base 10, so that is 1. So this was L, this is what we let, so it becomes L minus 1. Now we look at the power on right hand side. So that was log of x with base 100 and log of 2 with base 4. So the first term can be written as half log of x with base 10 plus half log of 2 with base 2, which will be equal to L plus 1 by 2. Now that means that our right hand side, if you see, is L plus 1 by 2. This is not 1, this is 2. That's a typing mistake. So L plus 1 by 2, when you have 9, so that will be 3 to the power L plus 1, because it will be multiplied by 2 because 9 is 3 square. So this is 3 into 3 to the power L. Once we have all this computed, we put this back into the original equation. We arrive at 6 by 5 dot 5 to the power L minus 3 to the power L by 3 is equal to 3 into 3 to the power L. That is 5 to the power L minus 2 is equal to 3 into L minus 2. Okay. So if you have doubt, you can perform the calculation and let me know if there is any issue. Okay. So if this is the case, so you see the powers of 5, the positive powers will be having 5 at the last digit. Even negative powers will have the same. And for 3, the last digit will rotate between 3, 6 and 9. No, it can also become, it will never be 5. It will never be 5. It can be anything, but it will never be 5. So how the rotation will happen is, if the last digit is say 3, Then from 3 to the power 3, when you multiply it will become 9. Okay, and once 9 is there, you multiply it with 3, it will become 7, the last digit. And once you have 7 at the last digit, it will be, the next multiplication will give you 1. And when you do with 1, it will become 3. That I'm only talking about last digits. And once it becomes 3, the cycle rotates. So 3 to 9 to 7 to 1 to 3. So in that fashion, the powers will rotate. Essentially, what I'm trying to say is that the powers have to be 0, equal to 0. Powers have to be 0. That is L is equal to 2, and then we have x is equal to 100 by taking antilog from here. Question 493 says that solve log of 5 to the power 1 by x plus 125 with base 5 is equal to log of 6 with base 5 plus 1 plus 1 by 2x. So again, very easy question. We consider what has to be computed. So we take 5 to the power 1 by x plus 125. So if you see this, okay, if you one moment. Okay, this is discard this. We don't need this. Okay, we look at the right hand side. So this is on the right hand side. This should be removed. Okay, so this we can write as what is given here. So what is happening is, let's reset this. Okay, what we have done is we have taken anti-log. Okay, so upon taking anti-log, this log with base 5 gets removed, and left hand side becomes 5 to the power 1 by x plus 125. And right hand side will become 5 to the power this entire stuff. So this can be further split into 5 to the power log of 6 with base 5 dot 5 dot 5 to the power 1 by 2x. That is 5 to the power 1 by x plus 125 is equal to, this is 6. So it becomes 6 into 5 into 5 to the power 1 by 2x. There again tapping mistake is there, it should be 2x. Now we take k is equal to 5 to the power 1 by 2x. So the equation becomes k square plus 125 plus 30k. You solve this equation, you have k is equal to 5 and 25, and x is equal to 1 by 2 and 1 by 4 from this equation. Question 494 says that solve x to the power 2 by 3 into log of x with base 2 whole square plus log of x with base 2 minus 5 by 4 is equal to square root of 2. So what we do is we take log of both sides with x. So what will happen is this x, when taken log of, will become 1, and this power will go as a coefficient. So we have the power here of the left hand side, and then we have right hand side will become half log x, log of 2 with base x, because square root of 2 can be written as 2 to the power 1 by 2. So it becomes half log of x, 2 with base x. Now this bracket is at wrong place. This should be here after 5 by 4. So left hand side does not change, and right hand side we change it as 1 by 2 to 2 into log of x with base 2. So we exchange the number with base and it goes in the denominator. Once we have that, we put log of x with base 2 as y. So the equation becomes y square plus y minus 5 by 4. Now this 3 will go to the numerator on right hand side, and 2 will come to the denominator, is equal to 3 by 4y. So we get the equation this. And whenever you have such an equation, look at the coefficient first. So the coefficient here is 4 plus 4, 8, minus 5, minus 3. So if the sum of coefficient is 0, clearly 1 will be one of its roots. So we divide this entire thing by y minus 1. We get 4y square plus 8y minus 3 to get two remaining factors, which is minus half and minus 3 by 2. So y is equal to one of the solutions, and then minus half and minus 3 by 2 are two other solutions. So we have three values of x, that is 2, 1 by root 2 and 1 by 2 root 2. Now we solve question number 495. Find all the real solutions of the equation 3x square minus 8 integral part of x plus 1 is equal to 0. So we let fractional part is equal to 1, then x is equal to, x becomes square root of 7 by 3. When integral part is 2, we see that x is equal to square root of 5. However, when we take mod x, integral part of x is equal to 3, then x becomes square root of 23 by 3, which is less than 3, which is not possible. Okay, whatever x you let, it has to satisfy the fact that integral part has to be equal to whatever you have let as. Okay, so since it is less than 3, the integral part will not be 3. Further values are not possible because if you increase the uh, integral part of x, the left hand side will increase exponentially. Okay, so for example, if you see this, it will not be solvable. Okay, what you would ask me, what do I mean by that? Okay, so assume that this is x. All right, don't consider it as integral part. Assume it is x. So let's take everything to the left hand side and look at the discriminant. So discriminant would be 8 plus minus square root of 64, 8 plus minus square root of 64, and this 1 and 4, 12. So you see that the roots have a finite range and other values will simply go outside finite range. Now what you can do as an experiment is, you can assume, if you want to actually find the range of the root, you assume that it is 8.99999. So you get the limiting value of the root as roughly 9. So that's why, not the value of root, I mean the max possible range. Okay, so that's how we arrive at the solution. Question 496 says that if t greater than 1, solve the equation t plus square root of t square minus 1 to the power x square minus 2x plus t minus square root of t square minus 1 to the power x square minus 2x is equal to 2t. Now here we don't have to find the value of t, we have to find the value of x. Okay, because this is one equation, there are two unknowns, you can't find that, so only one unknown, x, is required. So in this question, the most important thing is the observation that y plus 1 by y is equal to 2t. If you let y is equal to t plus square root of t square minus 1 and 1 by y is equal to t minus square root of t square minus 1. So once we have that, we substitute these obtained stuff and we get y to the power x square minus 2x plus 1 by y to the power x square minus 2x is equal to y plus 1 by y. So we let z is equal to y to the power x square minus 2x. This gives us the equation z minus y plus 1 by z minus 1 by y is equal to 0. Once we have that, we arrive at the fact that z is equal to y or z is equal to 1 by y. So once we have that, okay, you will get the solution as x is equal to 1 or 1 plus minus square root of 2. You simply substitute z is equal to y or 1 by y here and you will arrive at these results. Okay, so how do we arrive at this result is, if you put y is equal z is equal to y here, you get the equation x square minus 2x minus 1, and if you put 1 by y, you get the equation x square minus 2x plus 1 is equal to 0. So obviously one of those equations, x square minus 2x plus 1, will give you this root. Okay, because that is x minus 1 whole square is equal to 0. The other equation would be x square minus 2x minus 1. So if you look at the second term, that is minus 2, then the coefficient of the second term minus 2. So if you compute the root, minus b will become 2, and then plus minus square root of b square, that is 4 minus 4ac. So the coefficient of x square is 1, so 4 into 1, and the constant term is minus 1, so that is also 4. No, that is minus 4. X square minus 2x and then minus 1. Yeah, so that will become 4. 4 into 1 into 1, 4, and 4, 4, 8. So the square root will be 2 root 2. So essentially the entire equation will become, for the roots will be 2 plus minus 2 square root of 2 by 2. And that's what will give you 1 plus minus square root of 2. Question 497 says that obtain real solutions of the simultaneous equation xy plus 3y square minus x plus 4y minus 7 is equal to 0. and 2xy plus y square minus 2x minus 2y plus 1 is equal to 0. So there are two equations and we need to eliminate either x or y. Now one of the problems in elimination is this xy term, okay? So to eliminate, if you see, if you multiply the first equation by 2 and subtract xy will be eliminated. The other effect which you'll have is this x will also get eliminated, okay? And you will have terms only with y. So we do that and we arrive at 5y square plus 10y minus 15. That is, y is equal to minus 3 and 1. Now if y is equal to minus 3, we get x is equal to 2. And if y is equal to 1, then 0 is equal to 0. So all values of x in the set of real numbers will satisfy the equation. We skip question 498. There are serious typing issues. I'll have to fix that. Question 499 says that solve 4 to the power x minus 3 to the power x minus half is equal to 3 into x plus half minus 2 to the power 2x minus 1. So this is a very straightforward problem. We write 4 to the power x as 2 to the power 2x, and 2 to the power 2x minus 1 we take it to left hand side, and then 3 to the power x minus half we bring it to the right hand side. Now from this, if you take 2 to the power x minus 1 common, what will remain inside is 2 plus 1. So it becomes 3 into 2 to the power 2x minus 1. Similarly, this side, if you take 3 to the power x minus half common, then what will remain inside is 3 plus 1. So that will become 4. Once we have that, we can take 4 this side, 3 this side. What we will arrive at is 2 to the power 2x minus 3 is equal to 3 to the power x minus 3 by 2. And like the problem where we discussed the powers of 5 and 3, this time we have powers of 2 and 3, and you can draw the analogy, and x is equal to 3 by 2 is the only solution which satisfies both sides. Question 500 says that solve log of 98 plus square root of x cube minus x square minus 12x plus 36 taken with base 10 is equal to 2. So the first thing we do is we take antilog. And if you take antilog, the right hand side will become 10 to the power 2, that is 100. Subtract 98 from that, you will get 2. Then you square both sides, this 2 will become 4. Bring it to the left hand side, it will become 32. Now here the tricky part is to factorize this. How do you factorize? So that I will leave up to you. By mathematics of up to class 10, you should be able to factorize this. Okay. So the trick to factorize this is, I'll tell you, okay. The key to factorize is look at 32. What is it going to play well with? All right. So it can play well with 2, 4, and 8. Okay. And possibly 16. So you take x plus 4 and divide. Okay. You take, don't try with minus because this is positive. Okay. Then you try x plus 4 and you'll find that you get this. If you don't get with 4, then you try with 8, and then you try with 16, and finally you try with 32. So you won't need to get that depending on the equation. If the equation is different, you might have to try with different numbers. So that's how we arrive, and this will give us the what you call complex roots. And once it becomes a complex root, this entire thing will become complex because it won't remain 0. Okay, no, it will remain 0. This will become 4. But I think we don't want complex roots. No, it does not specify. So yeah, usually logs don't deal with complex root, but the thing is that if you put complex roots, it will become 0. It will become 4, sorry. So if you want, you can compute the complex roots, okay, and those should also satisfy the equation. So that I will leave it to you. But in general, with log, when logs are involved, we don't deal with complex roots. That is another aspect of it. But the key point is that this will become 4 if you put x as complex. So with this, we come to the end of the 50th set of problems. Not many problems are remaining in polynomials and theoretical equations. 54 more problems. And I will solve question 498 in the next video. So in 6 days, we should be able to finish this set unless I die or I fall sick. And then we will move on to very interesting topic of permutation combination, or in general, the chapter name is combinatorics. So we will have quite a bit of theory, roughly 20 pages of theory, and then we will solve the problems. So I hope that you are finding the videos useful and informative, okay, and it is helping with your studies, and I hope that you are working hard for your exams, or in general, exams or not, you should work hard to acquire knowledge. Knowledge is far more important than the marks which you have. The reason is that simply because some people don't do well in exams. Some people are just not built for exams. They take pressure and they buckle under pressure. Some people are tube lights, like me. I'm a tube light. Okay, I don't understand questions in one pass. I have to read them multiple times. So I'm not, for example, I'm not fit for exam. I never scored good marks in class. Okay. So with this, I will end the video and I'll see you in the next one. Till then, enjoy and sayonara.